Welcome to the quadratic function series. In this video, we shall learn how to express a general quadratic function to its completed square form. By definitions, a general quadratic function y has a quadratic term ax squared, a linear term bx, and a constant term c, where a, b, and c represent numbers. While the completed square form is written as y equals to a times x minus p all squared plus q, where a, p, and q represent numbers. The completed square form is particularly useful because the turning point x and y coordinates may be read off as p and q values respectively. Furthermore, the equation of its line of symmetry is given by x equals to p, since the line of symmetry coincides with the turning point. We shall now go through the process of completing the square to transform a general quadratic function to its completed square form. At the end of the process, p and q may be expressed in terms of a, b, and c. Let us start with a general quadratic function. The process of completing the square comprises 4 steps. Step 1. Factorize a from every term. Step 2. Add b over 2a all squared and subtract b over 2a all squared within the square brackets. In essence, this step introduces the terms required to complete the square without changing the function. In step 3, form the perfect square expression and simplify the residue terms. Notice that within the square brackets, the first 3 terms are collapsed into a perfect square expression. The fourth and the fifth terms constitute the residue terms. Step 4. Expand a back into the square brackets. This completes the process. At this juncture, it is important to note that if the quadratic function has a negative linear term, the perfect square expression follows as x minus b over 2a all squared. Comparing the completed square forms, we have the following results. P is equal to negative b over 2a. The equation of line of symmetry is x equals to negative b over 2a. And q, which is also the limit value of the function, is equal to c minus b squared over 4a. The coordinates of the turning point P, Q can be expressed in terms of A, B, and C. Let us now practice one question. Given the function y equals to 2x squared minus 3x minus 1, find the coordinates of the turning point. Start by completing the square for the quadratic function. Pause the video here and write your solution before comparing answers. Let's go through the process in this example. Step 1. Factorize 2 from every term in the quadratic expression. Step 2. Add 3/4 all squared and subtract 3/4 all squared within the square brackets. Step 3. Form the perfect square expression with the first 3 terms within the square brackets. Simplify the residue terms. Step 4. Expand 2 back into the square brackets and simplify all values. This completes the process. The completed square form of the quadratic function is then obtained. Comparing the completed square forms, we gather that P is equal to 3/4 and Q is equal to negative 2 1/8. Suppose the completed square expression is x plus 3/4 all squared. Think about what the values of p and q should be. Yes, we should rewrite the function to align the signs for the completed square forms first, and then compare the completed square forms to get the p and q values respectively. The turning point coordinates of this function is -3/4, -2 and 1/8. We have come to the end of the lesson. Here's a summary of the process of completing the square for a general quadratic function, and a summary of how to obtain the coordinates of the turning point. Note that special care has to be taken to align the signs before extracting the values of p and q. I hope you have learned something from this lesson. See you in the next video.